Hey guys, welcome to 3.3, increasing and decreasing functions and the first derivative test. In this lesson, we're going to be talking about the relationship between derivatives and increasing and decreasing functions. So let's go ahead and begin by refreshing ourselves with increasing. Increasing is when a function goes up from left to right, and decreasing is a function that goes down from left to right. So that if you have any two x values, for example x2, x1, their corresponding y values, for example, this would be f of x2, f of x1. If you choose any of these two x values, for example those two, in order for it to be increasing, that means that f of x1 must be less than f of x2. And that is what this definition is trying to say. Very similar to the decreasing. If I choose 2 points here and here, if that is f of x1 and then this is f of x2, then that means for any two values from left to right, the left one has to be greater than the one on the left and the one on the right. So that's what it means to be decreasing, and that is that definition there. Now, there's a special relationship between derivatives and increasing and decreasing functions, and I'm going to go ahead and show you it with the calculator app that I have here. So here I have a graph of a function. Now ask yourself, is this function differentiable? And your answer to that would be yes, because it is a continuous and a smooth curve. So let's go ahead and take a look at the slopes. What do you think this blue line represents here? This blue line represents the tangent line, which is also the derivative of the function at this x value. So that looks like to be x equals -4, and when x equals -4, my derivative is positive. Well, what's happening to the graph from left to right? From left to right, my graph is increasing. So let's go ahead and analyze the derivative. So my derivative is still positive when it's increasing, and then for some reason it goes to 0, which is my max. And then after my maximum, my derivative is now negative. See, this already switched. So it's going from positive to negative. So when my slope is negative, my graph is decreasing. And my slope is positive again, which means I'm increasing. Negative slope decreasing, positive slope increasing. Let's go ahead and extend this a little bit further. So when my derivative goes from positive to negative, I attain a maximum. And when my derivative goes from negative to positive, I attained a minimum. So we're going to go ahead and generalize this back in our notes. So on the second set of your notes, it says here, if f prime of x is greater than 0, or the slope is greater than 0, then that means that f is increasing, f is going up. If the slope is negative, f is going down, it's decreasing. And if the slope is equal to 0, that means we have a constant, or you could also say that you may have a maximum and a minimum, because the slope at these points are constant, 0. Now let's go ahead and take a look at the next part of your notes, the first derivative test. Let c be a critical number. What does a critical number mean? A critical number is when you have the derivative at some c equal to 0, or the derivative at some c is equal to undefined. Let c be a critical number of the function f that is continuous on the open interval I containing c. If f is differentiable on that interval, except possibly at c, then the point c comma f of c can be classified as follows. When the derivative changes from positive to negative, we have what's called a maximum, and that's what I showed you in the calculator. If the derivative goes from negative to positive, we have a minimum. So let's go ahead and just check that one more time. A derivative going from positive to negative is max. Yes, that's true. And from negative to positive, it's minimum. So yes, that's true. Now, one thing that you have to note, just because you have a maximum doesn't mean that this maximum is going to be the highest point. Notice this is a minimum. This minimum is actually higher than its maximum. So these are called relative maximums and relative minimums, meaning that they're not the global or the absolute max and min of the function. So I hope that helps you guys understand what's going on today. Today we're going to be talking about increasing functions and decreasing functions. Now, do functions always increase or do they always decrease? Well, no, they don't, because if you look at this is the same graph. On what sections of this graph or on what intervals of the function is this graph decreasing or the slope negative? Well, it's decreasing from what looks like to be -3 to about -1.5 and +1.5 to a +3. If I want to see where the graphs are increasing or where the slope is positive, it's increasing from -infinity to -3, -1.5 to +1.5, and 3 to infinity. So we can label increasing decreasing graphs by intervals. So let's go ahead and do the first example, and then on my next video I'll finish off the rest of the problems. First example, find the intervals where f is increasing and decreasing. Identify all points that are relative max and min. Justify your answers. What do we need to find max and mins? If you look at the previous definition, I need critical numbers, and critical numbers means that my derivative must be equal to 0 or undefined. In this case, I have a polynomial, a cubic function. Cubic functions are always differentiable, but there's never a point where the cubic function can be non-differentiable. So I'm going to be looking for critical numbers only when they equal to 0. So let's find the derivative. Set it equal to 0, and then we solve by factoring first. So it's -3x plus 1. And then when we set those equal to 0, we get x is equal to 3, x is equal to -1, and those are my critical numbers. Always label those as your critical numbers. Now, we don't know if x equals 3 and x equals 1 is a max or a minimum, so we have to test it using the first derivative test. The first derivative test says if my derivative changes from positive to negative, I have a max. From negative to positive, I have a min. So let's go ahead and number these, -1 and 3. Those are my critical numbers. Now there's no point in me plugging in these two numbers into my derivative because I just solved for it. They should give me 0. So I got to choose numbers in front of -1. For example, -2. In between -1 and 3, 0 is real simple. And then 4 would be the most easiest number to deal with after 3. So let's go ahead and plug these three numbers into our derivative, because we want to find if the derivative is positive or negative at these numbers, and that'll tell me whether it's increasing or decreasing. And if I can find a change of signs, then I know that I have a maximum or a minimum. So I'm running out of time, so I'm going to go ahead and continue this problem in the next video. So this problem we'll be doing the first derivative test, and then we'll be finding out the max and mins as well. So we're going to be determining increasing, decreasing, and max and mins in the next video.